In problem 2, let's see, we've got 3 over x minus 2 is less than or equal to 1. So this problem is almost perfect. There is one minor issue, is that the right-hand side is a 1, not a 0. So I need to move the 1 over to the other side so that I have a 0 on this side. So we'll subtract 1 from both sides. And what that now gives me is 3 over x minus 2 minus 1 is now going to be less than or equal to, well, we moved the 1 over, so now there's just a 0 on the right-hand side. Now we're still not set because now we've got 2 pieces on the left. We need 1. So I need to write this as one big fraction, so I need to get a common denominator first. So remember, when I've got the number 1, 1 can be rewritten, or any fraction can be rewritten as itself over 1. Then I would need to get a common denominator of x minus 2. So I'm going to multiply the top and the bottom of my 1 by x minus 2 so I can have a common denominator. And let's see what that does for me. Now what that does is I've still got my 3 over x minus 2 minus, I've got an x minus 2 on top and an x minus 2 on the bottom. And I've still got my 0 on the other side. But what's nice now is I forced a common denominator of x minus 2. So because I have a common denominator of x minus 2, I can put these together. And it will be a denominator of x minus 2. And we can add and subtract normally. However, this is something subtle that's easily going to throw off a problem if you don't catch it, that there's a negative sign out in front of your fraction, which does mean that I'm going to have to distribute that negative to both the x and the 2, which will give me negative x and a plus 2, so that when I add these two fractions, I'll still have my negative x. However, be careful. I will have my 2 and a 3, which are both positive now, which will now give me a positive 5. Now the other side is still less than or equal to 0. This is what we wanted, though. Remember, we want one fraction and 0 on the other side. That was our goal. However, that is just the setup we need just to even start the problem. Now that we have that set up correctly, now we can actually start the problem by looking for our critical values first. Remember, there's 2 parts to our critical values. 1, when does our top equal 0? Well, the top of this fraction is negative x plus 5, so let's set that equal to 0, because that's the top of our fraction, is negative x plus 5 equals 0. So the first thing you do is subtract 5 from both sides. That'll give you negative x equals negative 5. And then you'll divide both sides by a negative 1. That'll turn this x into a positive x. And it will turn the negative 5 into a positive 5. And remember what this is. This is where you're going to cross the x-axis, because this is when your fraction, your top, equals 0. Well, when your top equals 0, it means you'll end up with 0 divided by something will still give you 0, which is where you're going to cross your x-axis. Now, the second thing that we're looking for is when our denominator equals 0, when our bottom equals 0, which is when x minus 2 equals 0. That's the bottom of our fraction. So when does x minus 2 equal 0? You'll add 2 to both sides and you'll get x equals 2. And remember, this is what makes our function undefined, our denominator 0. You can't divide by 0, so this is when you have your vertical asymptote. So we've got a vertical asymptote, and we've got a value where we're going to cross the x-axis. Let's put our two critical values on a number line and have it help set up some regions to test. So we're going to put our first value on our number line, which is a 2. And then our second value on our number line is going to be a 5. Remember, the 2 is a vertical asymptote, so I'm going to draw it in as such, which is a vertical dotted or dashed line. At x equals 5, I've got where I'm going to cross the x-axis, so I should have an actual point there. So I'm going to draw that in. Now what this does is automatically, again, breaks this up into regions. We have a first region, that's anything before our asymptote, a second region, which is between our asymptote and our point, and a third region, which is everything that's happening after our point. So the next thing that we want to do is we want to plug in some values and see what happens. So we want to take one from each region, and we want to plug in a value to our function. So let's break this up. The first region is number 1, which means anything before 2. Well, the easiest and best value to choose that's before 2 is the number 0. Okay, what was our function or our fraction? Well, we want the one that was our goal. The one that has 0 on one side. So we'll use that one, the negative x plus 5 over the x minus 2. So let's plug in our value and see what happens. So we're plugging in 0 for x on top and 0 for x on the bottom. And on top we know it has a minus sign and a plus 5 and then a minus 2. What we do notice on this though is we have negative 0, which is still 0, plus 5 is going to be a positive 5, and then we end up with a negative 2 on the bottom. Well, if you have a positive on the top and a negative on the bottom, what do you end up with? Well, positive divided by a negative is a negative. So what does that mean about this first region if it ends up being negative is that it will be below the x-axis. Again, the x-axis is your number line. So here's our x-axis. Here's where you actually equal 0. So saying that you're negative means you'll be below that. So this first region where you're leading up to your asymptote is going to be completely below the x-axis. We don't know exactly what it'll look like, but probably something like that. Okay, next region. We need something from region number 2 next, which means something between 2 to 5. Let's choose something small. Let's try 3. And we're plugging it into our fraction again. So we've got a negative, and then we're plugging in 3 plus 5 over 3 minus 2. So notice you get a negative 3 plus 5 on top, which is a positive on top, and a 3 minus 2 on the bottom, which is another positive on the bottom. Well, a positive divided by a positive will still give you a positive value. So what that means is anything in region 2 is going to end up with a positive value, and it will be above the x-axis. So you'll still be at the asymptote on the other side, but you're going to be above the x-axis. One more region to look at, and that's going to be region 3, which is anything after 5. Let's use number 6 to plug in. And so we've got a negative, and then we'll have our 6 that's getting plugged in for x, plus 5 over, again, 6 gets plugged in for the x on the bottom too, minus 2. Notice the negative 6 plus 5 on top means you'll get a negative on the top, and you'll get a 6 minus 2 on the bottom, which is a positive on the bottom. So a negative on top divided by a positive on the bottom will get us actually a negative value. So in region 3, we're going to end up with negative values, which means we'll end up below the x-axis, which means our graph will just continue and slide underneath the x-axis. Okay. So we've gotten everything we need once we finish our picture and our number line. However, we need to go back to the original and see what we wanted. Remember, what we were looking at was negative x plus 5 over x minus 2. And let's see what it was. It was less than or equal to 0. Which means that we want the part of the graph, when we're saying less than or equal to 0, that's going to be below the x-axis, which means there's two portions of our graph that do that, the first region and the third region. So let's see how we're going to write that out. So our answer, which should be an interval notation by reading this graph from left to right, means we're going to start with region 1. Well, that means we start left at negative infinity and work our way up to 2. And then for region 3, we'll pick up at 5, and we'll continue along to the right towards positive infinity forever. As a reminder, both infinities always use parentheses. Also, what also is going to use parentheses always is the 2. Why the 2? Because it's a vertical asymptote and you're not going to touch it. So no matter what the problem says, we're always going to use a parentheses at 2 because it's a vertical asymptote. However, that is not true for 5. With 5, we have to be careful because it's an actual point. It's where you're crossing the x-axis. That means we need to look at the original problem, which has an equal to in it. Because it has an equal to and a point, we can go ahead and use a bracket. Now, the last thing is, how do you join these two pieces? Remember, you use the union or uniting symbol here. Do not use the U on your keyboard. You have to use the union symbol. They are not the same. But that's our final answer. And again, notice you have to be careful because vertical asymptotes always use a parentheses, even if you have an equal to in your problem, because you're not going to touch it. Last problem, let's take a look at number 3. So number